So today we're going to cover Chapter 9, Section 3. Today we're going to be focusing on similar right triangles. Now, we just finished Chapter 8 where we did similar polygons and we talked about just in general similar triangles. But today it'll be specifically right triangles. When you're doing the homework and on the quiz, you're going to be leaving your answers exact. Or it'll say simplest radical form or in simplest form. And what that means is you're going to have to enter it as a radical, a simplest radical form. For the questions where it's not a square root, if you're just solving a normal proportion, if you get an improper fraction, that's what Big Ideas wants, is an improper fraction when it says exact. Because if you divide it and you get a decimal and round it, you will get it wrong. So it wants simplified improper fractions. So make sure you're paying attention in the homework and for the quiz. So here is our first theorem, and it states that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So what's happening here is I have an original right triangle. So here is my original right triangle, the ABC. And then as soon as I draw in the altitude straight down here, it creates two smaller right triangles. So I have one here on the left, a little purple one. And then I've got another one over here on the right. So now I have formed three triangles. I've got the original blue one, then I've got a medium-sized red one, and then a small purple one. All three of these triangles are now similar. In the homework, they're going to ask you to write a similarity statement for the three triangles that are now formed when you've drawn in that altitude. So what I highly recommend you do is pull them apart. So I'm going to go ahead and I'm going to sit them all in the same orientation. So I'm going to put where the right angle is down at the bottom. So I'm going to redraw the blue one. I'm going to flip it over. So this is the original one. And notice the right angle is at the A. So I flipped it over. A is here. The shorter leg of the original right triangle is this AC. This is the shorter leg. And this is going to be the longer leg. And then BC here is the hypotenuse. So this is the original one flipped over. Now I'm going to draw the purple one and the red one. I'm going to do the medium-sized one first. Notice angle D is the right angle for both of these. So I'm sitting them all the same way, so it's easier to see the matches. So D is the right angle. The shorter leg is the AD. And then the longer leg is the DB here. And then I have the purple one. I got to flip it down. So again, the right angle is D for both the red and the purple. The shorter leg is the CD, and then the longer leg is the DA. So now they're all sitting the same way, and now it's going to be easier to write a similarity statement. And you're going to have to do this on the homework and on the quiz. Now, in the homework, if they start you out with something, like in order for the biggest one, then you have to match the other two. So let's say for the blue one, I decided to go from the longer leg to the B and then up here, the hypotenuse. So let's say I started out in the order of ABC. So then for the next one, I got to go the same way. I start at the right angle, and then I go over and up the hypotenuse. So start at the right angle, go along the longer leg, and then up the hypotenuse. And then do the same thing For the purple, start at the right angle, go up that way, and up the hypotenuse. Now, technically, it doesn't matter where you start. So like, for example, I could have started at the right angle and gone up and done ACB. But then for the next one, I got to go in that same direction. And that would have been DAB. So you pick a starting point, and then each one of the triangles has to go around in the same order. So be able to write a similarity statement. So let's say, for example, I told you that AB here of the original one is X. So let's say I put an X here. And then, let me go back. Let's say that's 8. AB is going to be 8. And then let's say I told you DA here, this altitude is a 4. And then I ask you to find this shorter leg. And let me give you one other thing, CB. I'm going to give you CB, this whole hypotenuse, I'm going to tell you is 10. Now, technically, I could do Pythagorean theorem here because I have everything I need. So you can use Pythagorean theorem, but let's say instead you wanted to match and use the purple and the blue. So notice if I go ahead and I match the corresponding sides and use the purple and the blue, notice I could put the two hypotenuses together, so the 10 and the X. And then I could match the 8, these two legs, the 8 and the 4. This is what we did in chapter 8. And this is what you're going to have to do for questions, I believe, 3 and 4. So you'll cross multiply, divide, and you find out that X is 5. So this side over here, the shorter leg, is a 5. Now sometimes if you have two of the sides, you could do Pythagorean theorem as well. So anything that I've taught you so far could be done to find these missing pieces. And some of them you will be able to do Pythagorean theorem to find it. But most of them you will have to use the proportions. All right, so let me go ahead and I'm going to do exactly the same thing. It wants me to identify the similar triangles in the diagram. So in other words, I want you to write a similarity statement. You're going to have to do this in the homework, and you're going to have to do it on the quiz. So my original one is here. This time, the right angle is sitting down here at the bottom. So let me redraw the original one. And angle T is the right angle of the original one. And then the shorter leg is the TS, or the ST, and then the R. Now, as soon as I've drawn in this altitude, it's now split and made a smaller one over here, and then a smaller medium-sized one over here. So I'm going to flip them over. Notice U here is now the right angle. So if I do the purple one first, the right angle, and it's U. The shorter leg is the UT, and then the longer leg is the RU. And then I'll do the little red one. Again, the right angle is U, and then the shorter leg is the US, and then the longer leg is the TU. So now that they're sitting the same way, it's a lot easier to come up with the corresponding matches. So notice the hypotenuse of the blue is the RS, hypotenuse of the purple is RT, and then the red is the TU. So again, when you come up with your statement, it doesn't matter where you start, just stay consistent. So let's say in the blue one, let's say I start at the right angle, go up the shorter leg into the hypotenuse. I need to do the same thing on all three. So if I start it here and say TSR, then for the purple, I got to go the same way, UTR. So then I would do the same thing for the purple. Start at the right angle, go up, and then down the hypotenuse. And then the same thing for the red. Start at the right angle, go up and down the hypotenuse. Again, if I give you something starting out, you have to match the other two in the same direction. And again, for the homework, most of the questions say exact or in simplest form. So if you get an answer that's a fraction, an improper fraction when you're trying to divide, if it turns into a decimal, then you need to leave it improper, okay? Let's say it's something like 35 over 25. I would expect you to simplify this to 7 over 5. Don't turn it into a decimal when it says exact. Okay, so a geometric mean, when you're given two numbers, all you're going to do is square root their product. So in the proportions that we're going to be seeing, or the theorems coming up, we're going to be finding a geometric mean, because two of the numbers that are going to be diagonal to each other are going to be the same. Sometimes they'll be numbers, but other times they'll be variables. And when it's a variable, we're going to have to square root it. And we're going to leave it in simplest radical form. So here I would do the cross products. X times x is x squared. A times b is just ab. And then you would square root that. So you're just going to multiply and then square root it. So on the quiz, again, I want it in simplest radical form. So let's try two examples of just finding a geometric mean. So here it wants us to find the geometric mean of the given numbers. You don't have to do the whole proportion. All you need to do is take the two numbers, multiply them, and then square root it. Now, technically, you're using a calculator, so what you could do is go ahead and multiply this and square root it. However, if the instructions say exact, and you square root this on your calculator, and you get 8.9 something, and you tell me this is the answer on the quiz, you will get it wrong. You have to do the factor tree and leave it in simplest radical form. So what might be easier to do is don't multiply them. Use the two numbers and just use that as your factor tree. If you don't want to use 4 and 20, you could do 8 and 10 or 16 and 5. It doesn't matter. So if I break this down, 2 and 2, 4 and 5, you could also do 2 and 10 on the 20. You're just going to keep breaking it down till they're prime numbers. And then you're going to go back and look for pairs. I have a pair of 2s, a 2 comes out. Another pair of 2s, another 2 comes out. This poor 5 doesn't have a pair, so he stays underneath. So in simplest radical form, the geometric mean is going to be 4 square root 5. Do not tell me it's the decimal rounded to the tenths place. Now, that's why it's easier probably to just leave it unmultiplied and do the factor tree. If you want to quickly do it on your calculator like the next one, and when you square root that product, if it gives you an integer, then you don't have to do the factor tree. And let me show you what I mean by that. So over here, if I take my 9 and my 25 and I multiply this, I get 225. And then if I hit the square root button, I get 15. So if you get an integer answer, then it's a perfect square. But if you get a decimal answer when you do the square root, then you know you got to go back and break it down. Now, in the past, we did not let students use calculators for this, so they had to break everything down. So in this case, you could have just done this. If you recognize 9 was a perfect square and 25, then when you multiply it, it's the same answer that I got this way. Or you could do the whole factor tree. So you have options on breaking down the radicals. So this theorem is called the geometric mean altitude theorem. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of the lengths of the two segments of the hypotenuse. Lots of words here.
Yeah.
Okay, so let's take a look at our picture here. So we have our original right triangle here. And what the words had stated is that when you draw in the altitude from the right angle, the original right angle, it splits this hypotenuse into two pieces. So this is the hypotenuse of the original right triangle. Over here, this is a leg of the original. We don't need this yet, but I just wanted to get it on here. And then this is also a leg. And then we have the hypotenuse. So when you draw in the altitude, it splits the hypotenuse into two segments. So I have segment 1 here, and then I have segment 2 over here. So it's split it into two separate pieces. And this is what we're using in our proportion. We're going to use the altitude and the two segments. So it'll be segment 1 over the altitude, altitude over segment 2. So when you're working the problems out, you're going to go ahead and maybe you're going to be given maybe the two segments, but not the altitude. And then the altitude where the red is, that would be your x's. And that's why you're going to be doing a geometric mean, because you would have to multiply the two segments and then square root it. Now, you could technically do like I did on that first slide and pull these three triangles apart and match the pieces as well. So if you forget the formula, you can also do it that way. So this is the geometric mean altitude theorem. Next, we're going to look at the geometric mean leg theorem. And we're going to have to use that proportion, one proportion for the pink leg and one for the gold leg. So let's take a look at that. So this one is the geometric mean leg theorem. And this one says that in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. Same thing again, but this time they've labeled it with A's and B's. So, and then it says the length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that's adjacent to the leg. So this last little statement here, the segment of the hypotenuse that's adjacent to the leg, I have an acronym for this, and I call this the SOHAL. Segment of the hypotenuse, so S from segment, O from of, H from hypotenuse, A from adjacent, and L for leg. So this is going to be the piece of the hypotenuse that's right next to the leg that we're trying to find. And I'm going to show you this in the two proportions that are here. So the A over here, this is going to be my segment 1. My B is going to be segment 2. And this is missing a C. There should be a little C here. This is the hypotenuse of the original thing, of the original triangle. This whole thing is the hypotenuse. And then this is Y is gonna be a leg of the original. And X is gonna be a leg of the original. And then I'm gonna add in another variable here. I'm gonna say this is the altitude, Z. Now I'm not using the altitude for this proportion, but sometimes you will. So for this first proportion that's listed here, the C over X, X over A, what this is it's the hypotenuse over the pink leg, that's the X, and then the pink leg goes here, and then its SOHAL, the A, is going to be segment 1. So it's the piece of the hypotenuse that's right next to the leg. And then I'll do the same thing for the gold. So this one, again, it's hypotenuse over the gold leg. So leg and leg. So these are both the same number or the same letter. You don't use the pink and the gold in the same thing. And then its SOHAL is the purple. So it's the piece of the hypotenuse that's right next to the leg you're looking for. So this would be segment 2, is its SOHAL. And then here, its SOHAL for the pink leg, the piece that the pink leg is next to is the blue. So you have to do 2 separate ones depending on which leg you're looking for. We're going to be using the geometric mean altitude and then the geometric mean leg theorem for the next 2 examples. And we're going to find all the missing pieces. For this one, I'm only doing A on this slide. So let me fill in what they've given me. They gave me, let's go ahead and label all this. So this is my pink leg. This is my gold leg. This is my whole hypotenuse of the original. This is going to be segment 1. You can switch up and which one is segment 1, which one's segment 2. It doesn't really matter. Just know that there's 2 segments. And then I also need to label the altitude here. All right, so then they gave me JR, which is what I've labeled to be segment 2. They gave me EJ, which is segment 1. So what I'm going to do first is work on finding my altitude, which is going to be HJ. So in order to find the altitude, I'm going to be doing segment 1 over altitude equals altitude over segment 2. And let me add variables in here. So my pink leg, I'm going to label as Z. My gold leg, I'm going to label as Y. My altitude, I'm going to label as X. So now I'm going to fill it in. So my segment 1, I had that measure. It's 9. I don't know my altitude. It's my variable X. And then my segment 2 is 16. So now I need to solve the proportion. So I'm going to multiply X times X. I get X squared. And then I'm going to multiply 9 times 16. Now, you could go ahead and multiply it if you want. Notice they're both perfect squares. This is going to give me 144. And then when you do this on your calculator and you square root it, you get X equals 12. And remember I said X was the altitude, which in this picture is my HJ. So HJ here is 12. Now, if this was not a perfect square, if you chose to multiply it and you got a decimal, then you'd have to go back and do the factor tree. Now let's work on finding the hypotenuse, because that is the RE. Well, for RE, the hypotenuse here, it's nice and easy because I already have the 2 little pieces of the segments. So for RE, all I have to do is add segment 1 plus segment 2, and I get the length of my hypotenuse. And once I add that, I get the length of the hypotenuse to be 25. So RE, 25. Now we're going to work on the 2 legs. So I'll go ahead and do the gold leg first, which is the RH. So I'm going to be using my hypotenuse over leg and it's the gold leg, over its Sohal, and remember the gold leg Sohal is the purple. So it's the Sohal, but it's going to be the segment 2. So let's fill it in. So I just found the hypotenuse. It's 25. I don't know the leg. My leg is Y. And my Sohal, segment 2, was 16. I'm going to cross multiply. I get Y squared equals 25 times 16. You're using your calculator, so I would try to multiply it and then square root it. This actually is a perfect square, and when you square root it, Y is equal to 20, which was RH. If it wasn't a perfect square, then you'd have to go back and do the factor tree. Once you get two sides of the right triangle, you can use Pythagorean theorem. And this would be another option that you would have to check your answers. However, if any of your sides or pieces become radicals, you will have to do the radicals in the Pythagorean theorem if you choose to do it that way. All right, let's now find the last leg, which is HE. So again, I'm using the same geometric mean leg theorem, but this time for the pink leg. So again, I'm doing hypotenuse, but this time it's going to be the pink leg that goes here and here. And its Sohal, the segment that it's right next to, is going to be segment 1. So I'm going to fill in the 25 for the hypotenuse. I don't know my leg. I said that was going to be the letter Z. And then its Sohal had a measurement of 9. So now I'm going to cross multiply. Z times Z is Z squared. And then 25 times 9. And then this, again, I would go ahead and try it on your calculator. 25 times 9 is going to give me 225. And then when you square root that, Z is equal to 15. Now again, if you weren't using a calculator, what you could have also done here is when you had the 25 and the 9, square root them and get 5 times 3, and you still get the same answer. And remember, Z was HE. So now I found all of the pieces of the triangle. So HE is 15. And then the RH, that was the gold leg, and that was the 20. Now the next one's going to have radicals. These were all perfect squares, so it was nice and easy. However, the next one, you're going to see that they aren't perfect squares, and we're going to have to break it down. Same picture, but now we're going to do B, and I'm going to label it the same way. So this is going to be Y again. It's a leg. Then I'll do the other leg in pink, and I'll call it Z. The whole hypotenuse is here. And then this is my altitude. This time I don't know one of the segments. This will be segment 1, but I'm going to call it X. And this time they gave me an altitude. They gave me the altitude to be 2. And they also gave me JR, segment 2 here, to be 4. So now let's go ahead and use our geometric mean altitude theorem to find segment 1. This time it's not going to be where we're going to have to square root something. So I'm going to go ahead and use my geometric mean altitude. So I'm going to be doing segment 1 over altitude and then altitude over segment 2. So I'm going to fill it in. So segment 1, I don't know. That's my X. I know my altitude this time, it's 2, and segment 2 is going to be 4. So now I'm going to cross multiply, and I get 4x equals 2 times 2, which is 4, divide by 4, and x equals 1. And remember, x, I said, was going to be EJ. So EJ, this x now equals 1. So now, to find the hypotenuse, I can take segment 1 plus segment 2 to get the length of the hypotenuse. So 1 plus 4, and the length of my hypotenuse is 5, which is going to be my RE. So RE is 5. EJ was 1. And then the RE is 5. Now we got to work on the 2 legs. So we're going to go ahead and we're going to be using the geometric mean leg theorem. So remember, that's going to be hypotenuse. And I'm going to go ahead and do the RH first, which is the gold leg. So leg, leg, and remember, its SOHAL is the purple. So it's going to be the segment 2. So let's fill it in. I just found the hypotenuse. It was 5. I don't know the leg. That's my variable y. And my SOHAL is 4. So now I'm going to cross multiply. Y times y is y squared. And then 5 times 4. And then if I multiply this, I get y squared equals 20. If you do this on your calculator, you're going to get a decimal. I want it exact. Big Ideas wants it exact. So what we need to do is square root it. And again, I would just go back to what it was when you multiplied. That's your factors of 20. And then 5 doesn't break down, but 4 does. I got a pair of 2's. A 2 comes out. So 2 square root 5 is the length of that leg, which is RH. So 2 square root 5 is RH. And now we just have to do HE, same proportion, but now we're going to do it with the pink and the blue. So again, hypotenuse over leg, this time it's the pink leg, equals pink leg over its SOHAL, which is segment 1. So let's fill it in. So again, I know the hypotenuse was 5. I said the pink leg was going to be Z. And my SOHAL I found, which was 1. So now I'm going to cross multiply. I get Z squared equals 5 times 1. And then I got to square root it. When I square root it, I can't break anything down, so Z is equal to the square root of 5, which is the last thing, the HE. So that leg is the square root of 5. And again, once you find these pieces, if you have 2 of the sides of the right triangle, yes, you can do Pythagorean theorem to check.